Okay, we're on unit 2.5 and 2.6, and we are going to find the derivatives implicitly. And remember the idea of implicit differentiation. The idea is we could actually, and don't write this down, but we could actually solve this by subtracting x squared from both sides. We would have y squared is equal to negative x squared plus 36, and then take the square root, and we would have y is equal to plus or minus the square root of negative x squared plus 36. And so that would be y written in terms of x. It's written explicitly, and we can do explicit differentiation, which isn't very fun when you're looking at an equation like that. It's a little more complicated. And so we learned that it's easier to find the derivative implicitly. Okay? Now, remember when we are finding the derivative, it's actually dy dx is the derivative. That's the derivative of y with respect to x. And recall that part of the reason is when we're finding the derivative, we're finding the slope of the tangent line at any point. So the idea of y over x is kind of built into that. But we are taking the derivative with respect to x. And so what we would actually do if we were going to write this whole thing out is we would say, okay, we're going to take the derivative of this piece of the function x squared with respect to x. And we've got to go back to our derivative rules, and what we have is the derivative of a sum. So the derivative of a sum is the sum of the derivatives. So we're going to take the derivative of the first piece of that polynomial with respect to x, plus the derivative of the second piece of that polynomial with respect to x is equal to the derivative of what's on the right side, that constant with respect to x. So that's how we would write it out formally. Now, this is doing normal derivative stuff. So the derivative of x squared, remember we take the exponent times the coefficient 1. 1 times 2 is 2. We reduce the exponent by 1, and so we're going to get 2x. When it's with respect to x, then it's just that. Now, when we take the derivative of y squared with respect to x, we still use that same rule. We take exponent times coefficient 1 is a 2, and then reduce the exponent by 1y, and it's a plus because of the derivative of the sum is the sum of derivatives. But remember, when we have a y there, what do we have to put? We have to put y prime or a dy dx. Now, if we're going to find it in terms of dy dx, then we could write it like that. We're going to go ahead and do that. We're going to go ahead and write the dy dx, which you could just write y prime, we know. Now, is there some symbol in there? Plus, minus, times, or divide? Remember that that's really a times sign, although it's understood. And why is it a times sign?
Because you're multiplying dy over dx by 2y.
Why are we multiplying dy over dx times 2y? Okay, it's really the chain rule. Remember that? It's the idea of the chain, which is the derivative of the wrapper times the derivative of the guts of the wrapper. So it's kind of the idea of the chain. So the implicit part, dy dx, is multiplied to the other with the idea of the chain rule. And then on the right side, the derivative of the constant is 0. So we have equal to 0. Okay? All right, now, what do we do now?
Remove the 2 of x.
You make sure all of your dy dx terms are on one side, right? And if there was more than one, we would factor out that dy dx term. So we want to isolate the dy dx, basically. So we're going to get all of the terms that do not have that to the right side, and all the terms that do have that to the left side. So this term will move over there by subtracting 2x. We probably don't have to show that step anymore, but anyway, so we're going to have 2y dy dx, which we could have written as y prime, is equal to negative 2x. Now we can undo multiplication by division, which was important for us to know that that was multiplication. It is because of the chain rule. Now we're going to undo what's multiplied to the dy dx. We're going to undo that by dividing. We're going to divide both sides by 2y, and we get dy dx is equal to negative 2x over 2y, which will reduce to negative x over y. So this is the derivative of y with respect to x, and it was calculated explicitly. Now, what does that represent? What does derivative always represent? The slope of the tangent line at any given point. And if we wanted the slope of the tangent line at some point x, y, then what we would have to do is plug in the x and the y. When we solved explicitly, we only had to plug in the x because the answer would be given in terms of x, not in terms of x and y. Okay? So it's not that big a deal to end up with an x and y. We just plug in both parts of the point when we look for the slope of the tangent line at a specific point. Any questions on number one? Okay. Number two. Now, we've got to recall not only explicit differentiation, but we have to recall the rules of derivatives to begin with. We have to be careful lest we let our guard down and make mistakes. So, remember back in Algebra 1, I would have you say, now what's the operation and what's the rule for that? You know, you got to remember to do that. The operations are multiplication and subtraction, and what's the rule for that? Well, the rule for multiplication is what? We're talking about derivatives, so what's the rule for multiplication?
Derivative of the first times second plus derivative of second times first.
Good, so first times derivative of second plus second times derivative of first, or vice versa. If there's three of them, it would be 2 times derivative of the other, plus the other 2 times the derivative of the other, plus the other 2 times the derivative of the other, okay? The product of 2 times the derivative of the third, the product of the other 2 times the derivative of the third, etc. All right, and then the derivative of a difference is the difference in the derivatives. Okay, so we'll just take the first part. Let's just kind of do this a piece at a time. So we'll do the first part. We're going to have the first times the derivative of the second. Now, when you do the derivative of the second, what are you going to get?
3y squared.
3y squared, but we have to insert
No y.
the dy dx, which actually was a piece of the chain rule. Now, that's just the first half of that. So we have first times derivative of second plus second y cubed times the derivative of the first, and the derivative of the first would be 3x squared. Now that does not have a dy dx. So that took care of the green box, right? The derivative of the product is first times derivative of second plus second times derivative of first. The derivative of a difference is the difference in the derivatives. So now we're going to take the derivative of y, which would be, okay, so it's like a 1, right? That's like an understood 1. I'm going to go ahead and write that, okay? The derivative of y is 1, but we want it in terms of then times the dy dx. So the derivative of the y was 1, but when we're doing y with respect to x, then we have to write the dy dx. And then over here on the right side, I'll go ahead and put it in red, is equal to what's the derivative of x? 1. So well, now we have this equation. In this particular equation, we have 2 dy dx terms. And again, what you want to do is to move all of the terms that do not have a dy dx to the right side and leave all the terms with a dy dx to the left side. And the term that does not have a dy dx in it is that one. So if we move that across, and I'm going to kind of clean this up a little as we go, we would have 3x cubed y squared dy dx, and then minus dy dx equal, and then moving this term to the other side would change the sign, so that would give us negative, and I'm going to go ahead and put the x first, 3x squared y cubed. Everybody good with that? So what we've done is we've left the terms with dy dx on the left, and now we can factor out that dy dx. If we factor out that dy dx, and I'm just going to put it second, we would have dy dx times 3x cubed y squared minus that 1 that we took off, right? That understood 1 is equal to negative 3x squared y cubed.
Wouldn't it be a plus 1 on the right side?
Plus 1 on the right side. Thank you. We left that 1 off. I still had a 0 in my mind from the last problem. Like that 1 wasn't there. Sorry about that. My mind was saying that was a 0, and I didn't even look. You're right. So we moved that term to the other side, and we still have that plus 1. Thank you. Now we can divide off what's on this factored out dy dx. So we're going to have 3x cubed y squared. There's a plus 1 right here. I'm going to put that in. I almost forgot it again. Divide 3 y cubed x squared.
X way much better.
And I've got a minus 1 here. I'm just having trouble here. Excuse me. Sorry about that. Let's get this right. I keep losing my 1's today. So we're going to divide by 3x cubed y squared. There you have minus 1. We need that minus 1 on there. And then we're going to divide by 3x cubed y squared and my minus 1. There we have it. I was trying to lose pieces of a puzzle there. All right. And that's really about as simple as we can get it. So the derivative of y, we'll just write it again. The derivative of y with respect to x is negative 3x squared y cubed plus 1 over 3x cubed y squared minus 1. Okay. Any questions on number 2? And again, it looks a little messy, but this represents the slope of the tangent line at any point. And if we were given a point, all you have to do is plug in the x and y and solve. And it's not that complicated to get the slope of the tangent line at any given point. Okay. Any questions on number 2? Okay. Number 3. Number 3, we're going to differentiate explicitly. I think it might be important here to go ahead and think about what we have. We've got addition. Right here, we have a constant rule, 2 times. So that's not a problem. It's just 2 times whatever. We can kind of line this out maybe in our mind and say, okay, I'm going to have a plus sign because the derivative of a sum is the sum of derivatives. And then over here, I'm going to have the constant rule 2 times whatever that rest of that mess turns into, right? But then what do we have right here if I take that constant off? We have a chain rule. And that's because there's an understood parenthesis here, right? So we're going to take the derivative of the wrapper, right? And then the derivative of the guts of the wrapper, as I said. Okay? And so we have to think about that. So let's move to the left side and go ahead and take care of that first. What is the derivative of sine x? Cosine x. So that one was easy. Now, what is the derivative of cosine? Negative sine. So we're going to have negative sine of whatever that is, 2y, right? But then we have to do the chain rule, so we go times the derivative of the guts, right? We want the derivative of the wrapper. The wrapper is cosine. The derivative of that is negative sine, and then with the guts attached. And then times the derivative of the guts, what's within the parenthesis, and the derivative of 2y is 2, but because of the y, we have to put dy dx. Right. Until we got to that point. So we have to be very careful because we've got a lot of things going on. And then equal, and the derivative of a constant is 0, so we have a 0 there. Okay. All right, now, it would probably be good to go ahead and distribute here. Notice how that, I'm sorry, we're not going to distribute there because that's not a plus or minus. Yeah, I said that. We're going to go ahead and multiply by the constant. So we're going to have cosine x plus 2 times that 2 times that negative. We'll make that a minus 4 sine 2y dy dx equals 0. So we did that multiplication. We multiplied by the constant. So we got this 2 times this 2 times that negative 1. That negative. So 2 times negative times 2 is negative 4. And then the sine 2y and then the dy dx. Yeah. Okay. Now, we've got a dy dx here, so we want the dy dx terms on the left. This term does not have a dy dx, so we move it to the right, which would change the sign. We're going to have negative 4 sine 2y dy dx is equal to, when we cross over, we change the sign, negative cosine x. Now we can divide off what's on the dy dx. So we're going to divide off the negative 4 sine 2y. And so we're going to have dy dx is equal to negative cosine x over negative 4 sine 2y. But we need to simplify according to the rules of trigonometry. So how can we simplify that?
Get it into in terms of sine and cosine.
But and it's already in terms of sine and cosine. And I was wondering if that would hit your mind. We heard the word cotangent, and then you said no, and the reason is it's cosine x and sine 2y. If it was cosine x over sine x, it would be cotangent x, but you can't do that. All we can do is, we know that we really don't want that on the bottom, right? So what's the reciprocal of sine? Cosecant. So we'll just move it to the top as cosecant. That's the only simplification that we can do. Now, we do have a negative divided by negative. We'll go ahead and do that and make that positive. So we're going to have a positive cosine x. Moving the sign to the top would make it cosecant of 2y, and then over 4. Okay? And that's about as simple as it gets. Any questions on number 3? So we dealt with the derivative of sine and cosine, and we dealt with the chain rule with that cosine of 2y. We also dealt with that constant 2 rule, and we just pulled it off, found the derivative, and then multiplied. Okay. Any questions on number 3? All right. Now, number 4, it takes us one step further. It says find the derivative implicitly and then evaluate the derivative at a given point. Now we need to plug the point in, okay? Again, it's important that we think about the order of operations, as you realize, because we've got to apply the derivative rules to those, just like we did the very first day in Algebra 1. So what's the operation? Multiplication. What's the rule for that? First times derivative of second plus second times derivative of first. Okay? So we're thinking order of operations, and we're thinking what's the rules for those things. Okay, so with that, we're going to say first times the derivative of second. Now, what's the derivative of y? Was understood 1 times the dy dx, which gives us a dy dx, is equal to the derivative of a constant is 0. Okay? Let's see what we got there. And then we have, I messed up. We forgot about the second half. So, forget I did that. So that was the first part of our multiplication, right? So to multiply, we have first times derivative of second plus second y times the derivative of the first, and the derivative of x is 1. There you go. Is equal to the derivative of that constant, 0. Easy to let your guard down. You got to stay on your game or you'll make little mistakes. And so what we have, if we just go ahead and write this, is x dy dx plus y equals 0. We want the dy dx term by itself, so we're going to move the y to the other side. Remembering to change the sign. So that gives us x dy dx is equal to negative y. Now we can divide off the stuff on the y. And so we have dy dx is equal to negative y over x. So we have found the derivative of y with respect to x, which we could write as y prime. I just wanted to have the dy dx stuff here, just to focus on that idea. In terms of x and y. Now, it asks us to evaluate the derivative at a given point. And so we have this point xy, and we'll just plug those in. So we're going to have the negative of negative 1, the negative of negative 1, over x, which is negative 4, which gives us positive 1 over negative 4, but we don't leave the negative in the denominator. When you divide with different signs, the answer is negative. So the slope of the line tangent to that curve at the point negative 4, negative 1 would be negative 1/4. That is the slope of the tangent line at the point. You know that we could take that point and that slope. We could write an equation of that tangent line in point slope form, change it to slope intercept if we wanted to, so we could go one step further. Okay. Any questions on number 4? Okay. Number 5, same situation. We do want to focus on our operation so we don't make any mistakes, and then refocus as we go, so double check ourselves. We have the operation addition, we have multiplication, and we have addition. Now, we know that the derivative of a sum is the sum of the derivatives. And we know that the derivative of a sum here is the sum of the derivatives. And on the product, we also have a coefficient rule, right? And I could actually write this like this. I'm going to stretch this out. Equal. We have a coefficient 4 times something. And then we're going to have plus that constant rule. Okay? So that's kind of how that separates out. The derivative of the sum is the sum of the derivatives. I'm going to highlight here just so I can say it. The derivative of a constant is a constant times the derivative, and what would go in parentheses is the derivative of xy. And then we have the derivative of a sum is the sum of the derivatives, okay? So we're thinking out like that. And then we're going to take each piece. The derivative of x cubed would be 3x squared, we know, and we won't go through all that again, we've got that. And then the derivative of y cubed would be 3y squared, but on that one we need the dy dx. Almost could give myself a number. And then equal, we have for that constant times. Now, the derivative of a product is the first times the derivative of the second, which would be dy dx. So we have x dy dx plus the second, which would be y, times the derivative of the first. The derivative of x is 1. And then times that constant 4, which gets distributed this time, see, because there was the product rule and now there's a plus in there, so now the 4 gets distributed. I was wanting to do it a while ago and it wasn't time. And then the derivative of 0, that constant, the derivative of that constant is 0. The derivative of 1 is 0. I said that backwards. Okay. All right, so we're going to go ahead and, let's go ahead and distribute over here that 4. And so what we're going to have is 3x squared plus 3y squared dy dx equal, distributing the 4, we're going to have 4x dy dx, and then plus 4y, and then 4y. Two y's you are. 4y. And then the 0 goes up. Okay, again, we want to take all of the terms that have a dy dx on and move them to the left, and all the terms that do not have a dy dx and move them to the right. So this term needs to go across there, and this term needs to go across here. So we're going to have 3y squared dy dx. Moving this term across changes that 4 to a negative, so minus 4x dy dx equal, moving this term across will make that 3 become a negative, negative 3x squared, and then we still have a plus 4y. So we've moved our dy dx terms to the left side. So now we can factor off that common factor of dy dx. If we put the factored off part in parentheses first, we would have 3y squared minus 4x dy dx is equal to negative 3x squared plus 4, and again 4y. I'll do that all the time. Okay. So now we can divide off the stuff on our dy dx. So we're going to divide off the 3y squared minus 4x. And we're going to have dy dx is negative 3x squared plus, there it is again, 4y over 3y squared minus 4x. So there is the derivative of y with respect to x. The derivative of y with respect to x. Now, it said evaluate it at the point 2, 1. So we're going to plug that in. So everywhere there's an x, we put a 2 it. Everywhere there's a y, we put a 1. We're going to have negative 3 times my x of 2 squared plus 4 times my y of 1 over 3 times my y of 1 squared minus 4 times my x of 2. So again, the equation is the slope of the tangent line at any point, and now we're plugging in a specific point, and we're getting the slope at that location. And so we'll just do this in our head. We've got 2 squared is 4 times negative 3 is negative 12 plus 4 is negative 8. And then we've got 1 squared is 1 times 3 is 3, and 3 minus 8 is negative 5. And when you divide with the same sign, the answer is positive, so we have positive 8/5. That is the slope of the tangent line at the point 2, 1. Up 8, right 5, if we actually apply it. Any questions on number 5? Remember how we started finding derivatives the very first time? We used the what? Remember what we called it? The difference quotient. We use the difference quotient, which is changing y over changing x, y minus y over x minus x. Again, and that y minus y, change in y, x minus x, change in x. We're going back to that. So don't forget where all this came from. It came from changing y, changing x, y minus y, x minus x. And we did it longhand, and then we learned about derivative rules. And now we're skipping the difference quotient, but we still end up with the same result. Slope, which is changing y, changing x. Any questions on number 5? Okay. Number 6. Number 6, again, we have to think, what's the operations and what's the rules for that? Well, we actually have a multiplication, and we also have a what? Well, if this was a 2y, we would have a parenthesis and a chain, right? So we want to think about that, but there's not a 2y, so it's not really a chain. But if there had been a 2 there, it would have created a parenthesis, and a parenthesis creates a chain. So we really only have one operation, which is multiplication. Now, to find the derivative of a product, you take first times the derivative of second, which would be negative sign y, plus the second cosine y times the derivative of first, and the derivative of x is 1, so that stays the same. And we've done the only operation there is equal to the derivative of a constant is 0. So we got that. Again, don't forget, if that y right here had been a 2 times y, then it would have been like cosine of 2 times y, which would have created the chain rule, right? Okay, a parenthesis creates a chain rule. All right, so we're good with that. All right. Now, we forgot something. We forgot our dy dx. Back up.
Okay.
There is a chain, but it's the dy dx chain, right? So the derivative of cosine y is negative sine y, but when we're finding the derivative of y with respect to x, we have to insert the dy dx. Is equal to the derivative of the constant is 0. There we go. Whoops, then I forgot the rest. Okay.
Plus cosine.
All right. Let's just start over, because I'll start over just from the video tape. Okay, we've got multiplication. We made a little mistake. I'm just going to do it from the start. We're going to have first x times the derivative of the second. The derivative of cosine is negative sine y, but because there's a y, then the chain rule applies, and we have to put our dy dx. Now that's just the first part. That was first times derivative of second. Now we have to say plus second cosine y times the derivative of the first, and the derivative of x is 1, so that stays cosine y. Now we can put our equal sign. The derivative of a constant is 0. There we go. Well, you got to be careful. It's easy to make a mistake. Okay, it's probably not bad to see that in the video, so those people watching the video realize, hey, it's easy to do, we just need to pay attention. Now, again, the terms that have dy dx stay on the left, and the terms that do not have the dy dx go to the right, so we need to move that cosine y to the other side. I'm going to kind of put those together and stick the x in the middle there, so we have negative x sine y dy. I lost my d on the x there. Dx is equal to, when I move that cosine over, it changes signs, negative cosine y. Very good there. Now, I can divide off the stuff that's on the dy dx, so I'm going to divide off the negative x sine y, divide off the negative x sine y, and so I'm going to have dy dx is equal to, maybe we can go ahead and do this here. What's a negative divided by a negative? A positive. Now, these are the same this time, right? Cosine y over sine y. Cosine over sine is cotangent, so we can write that as cotangent y. And then we still got that x on the bottom. So we end up with cotangent y over x. Cotangent y over x. Now, you don't have time for me to change this? So we're going to plug in that point. And so we're going to have cotangent of the y, which is pi over 3, over my x of 2. And so then we think, well, cotangent pi over 3. Let's go back and think about that. Pi over 3 is the same as how many degrees?
60 degrees.
180 divided by 3, and I probably shouldn't be doing this in calculus, but this is just trig stuff. Is 60 degrees, so my reference is 60. And we know that the tangent of 60 degrees, the tangent of 60 degrees is?
Square root 3 over, no, that's just.
Now, when you look at tangent, if you remember those, 30 degrees and 60 degrees. One of those, they both have a square root 3 in them, and one of them has an over 3. And the tangent of the smaller number would give us the smaller result. Okay? So both of those have a square root 3. The tangent 30 has the over 3 because it's going to be smaller than the tangent of the bigger. Now, so tangent 60 is square root 3. Therefore, the cotangent.
Beta students, you need to come get a medical release form, a permission form, and a schedule for convention. All Beta students who are going to convention need to come by my room and see me today to get those papers. They are due tomorrow. See me today.
Okay? See how it happened? Rationalizing the number. Okay. So we're going to have square root 3 over 3 over 2, which ends up being square root 3 over 6. A lot of trig stuff hiding in there. Any questions on that? So you've got a trig table that I gave you at the first of the year. You might want to go back and study that. Just a little bit of some of that stuff is left here. All right, that's a pretty good run. We got 1 through 6 done. We'll take a look at some of the others next time. Appreciate your attention.